So, dobar dan, hello. My name is Dalibor Topić. As you can see from my name, I'm German, from Hamburg in Germany. I work for Oracle in the product management team in Java, mostly in OpenJDK and things like that. I've been here before. It's been always a great pleasure, so it's great to be back at GeeCON. And today I'll talk about the things we're doing with the project Jigsaw and JDK-9, both of which are, I think, fairly exciting topics and fairly upcoming new things. Speaking of upcoming new things, if you've seen a presentation from me in the prior years or one of my colleagues from Oracle, you're probably familiar with this safe harbor statement. And while you take a moment to enjoy it, I'll take a moment to enjoy a sip of local water. And since you're all fast readers, let's just move on. So, the more things change, the more they stay the same, right? And a lot has changed over the past year. There was Brexit, there was Trump. A lot has changed, right? But some things never change. And if you're a Java developer, you know what I mean. So if you open up your news reader every couple of weeks, you'll find one of those excited articles pronouncing the imminent end of Java one way or another, either by action or inaction, or often also very popular, on the hands of some other programming language. And this is like a meme that keeps coming every couple of weeks. You'll see an article that pronounces this. So for example, a couple of weeks ago, I found an article that exclaimed that because in the Topić survey, Java went a couple of points down, that must have been it. That must be the death knell, one way or the other. Of course, Java is still #1 on that survey and is so by a significant margin. Nevertheless, it doesn't stop an article being written about it. A couple of weeks ago, there was another article questioning the future of Java because the university had chosen to use a different programming language for a course. Scary stuff, right? And so if you're a Java developer, you're familiar with this, with this Java is dead meme coming up over and over again in say, news blogs and so forth. It's like a regular heartbeat of excitement where every couple of weeks there will be a post pronouncing the end of days for some reason or other, and then you realize, well, maybe that's not quite it, right? The plugin doesn't quite matter that much in this scenario and so forth. And there's something else that comes up and is exciting, and that also does lead to the end of Java and so forth and so forth. And the fact is, this kind of meme has been with us for a long, long time. In fact, almost as long as Java has been around. So if you go back in time, without a time machine, just using your favorite search tools, you'll be able to find articles pronouncing the imminent end of Java since at least the early 2000s, if not the mid-90s, because of, say, some of the other reason or some of the other programming language. At one point in time, it was Python. That was before Python 3, I think, that was supposed to end Java forever. Then at some point, it was Ruby, and maybe even Perl 6, although I'm not quite sure about that one. So if you go far enough back in time, you'll notice that actually there is one fascinating pattern about all these. Even though such articles keep showing up and being written, the frequency with which Java is dead as a meme has been around, has actually significantly decreased over time. So those were the days back in the early 2000s when this was a big meme. But then sometime after the Oracle acquisition, actually, the meme basically became the programming language equivalent of the year of the Linux desktop. So sure, it got its play every now and then, but it didn't really matter that much because, surprisingly, Java has been incredibly stable over the past couple of years, even though if you look at, say, just the news, you may not quite get that impression. Because, of course, the update releases, for example, have been coming out like a regular clockwork every couple of months. And I'm sure you're all keeping your systems up to date, right? With the critical patch updates, as you should. And also because the major releases have also started to come out in a much better, much more predictable schedule. We had 8 a couple of years ago, now 9 is on the road. And so we live in a lot more vital times than was the case before for the platform. As such, you may wonder what to make of headlines like these, headlines with asking whether Jigsaw will lead to fragmentation of community. Well, I have a bit of advice for you. When in doubt, go to a source of knowledge, in particular one you can edit yourself, so that if the knowledge doesn't fit, you can always edit it. And Wikipedia says there is something called Betteridge's law of headlines. And it says any headline that ends in a question mark can be answered by the word no. So anytime you read news asking, is Java dead? Is Java 9 dead? Is Jigsaw going to kill something or other? The answer is probably no. Right. And so, what does Jigsaw actually do? What is this thing? Well, Jigsaw is a project. In particular, it's a software project in the OpenJDK community. It has a bunch of goals, of which there is 3 that are, I think, very, very crucial to what we all do. Firstly, to make the Java platform smaller. Secondly, to make it safer. And thirdly, to make applications on it faster, while providing a module system that makes it easier for developers to provide libraries and complex applications using it on top of the Java platform. Jigsaw is being developed in the OpenJDK community. OpenJDK is an open source community that was established by Sun Microsystems. Some of you may remember Sun, the older ones at least, actually almost 10 years ago. So pretty much this week, 10 years ago, Sun published the full source code of the JDK7 then back in development on the internet, on the openjdk.dev.java.net site. That was, I think, at least 3 JavaNet migrations ago. And put it there for everybody to use and contribute to. And use and contribute people did. In the beginning, this was Sun, and then companies like Red Hat and Canonical that joined the fray and helped bring OpenJDK on Linux distributions and package it in those systems to make it easily available for everybody. And then after the Oracle acquisition, a number of other companies traditionally more involved with Java came on board, such as IBM or Intel and AMD. A number of research institutions came on board, and of course, a number of individual developers. And the great thing is, of course, everything that's happening in OpenJDK is actually happening out there for you to see and participate in the open. So projects like Jigsaw have mailing lists. That means you're not necessarily have to rely on waiting for blogs to come out if you want to follow the latest developments. You can actually subscribe to a list and see for yourself what's being discussed and what's being deliberated in terms of modularity, for example, features and changes. These mailing lists are fairly active, so Jigsaw has been going on for quite a while, for almost as long as OpenJDK itself, actually. And it has seen significant amount of traffic. So if you like email, if you like a lot of email, every month in your inbox with patches and reviews and features, that's the place to be. And it's also a place to be even if you're not somebody who's necessarily deeply involved in JDK development itself. So in course of development of Jigsaw, we've seen a number of developers outside of Sun and Oracle contribute their feedback, their bug reports, their ideas, their criticisms to the Jigsaw development team. And the way we create those runtimes is using a new tool in JDK9 called JLink. And as the name implies, it's a linker. So it's the first time we have a linker tool in the JDK. What this tool does is it takes a set of modules along with the dependencies and resolves all the dependencies, resolves the dependencies they have on the JDK itself, on the JDK modules, and pulls them all together into one coherent whole, into a custom runtime image that only contains the modules required to build and run the application and nothing else. And that means the resulting JDK for this application and for these libraries can be very compact. So for example, in a minimal install where you just have, say, the base module and maybe a bunch of local data for Polish or for French or for German, you can end up with a minimal runtime that's somewhere between 20 or 30 megabytes, depending on whether you compress the resulting image and strip out debugging information or not. And that's not quite as good as, say, you can get by just writing assembly code by hand, but it's not a bad start, given where Java is coming from. And why don't you actually show you a bit of things here, how this works. So, like in a coding show, I prepared something. I have a bunch of source code, and because we don't have much time, let's do the enterprisey kind of example first. We have an application here that uses a library. Our application is in COM greetings. It's, of course, your typical, hello world application. And because if hello world works, I mean, everything works as well, right? And so what it does, it imports from the org-astro library the type world and prints out a greetings message. Because our application in the modular world is a module itself, it has an associated module descriptor. And those are in Jigsaw in module info Java files. So in this case, we have a module com greetings, and this application requires a different module called org-astro by name. So this is going to be the name of the module we require. Our org-astro library, in turn, has just one type, which does pretty much what you expect it to do. It just returns a string. And it also has, because it has to be a module in the modular world, a module descriptor, which is very simple as well. Module keyword, its name org-astro, and then an exports clause where it says which packages contain types it exports to its users. And the module system takes care of bringing these two things together, both at compile time and at runtime, and making sure declarations are actually resolved and match against each other, so that the dependencies we declare in our modules are resolved properly, and the types we export for our users to use as library authors are the only types that the users actually get access to. And this helps us have strong encapsulation as part of our modules, which prevents, say, accidental usages of internal functionality, something the JDK has had to struggle with for a long time. Okay, because all of these are Java files, let's just build this, and we'll build this using the Java compiler. So Java C, and then it goes off and builds stuff for us quickly, hopefully. Right, okay. We'll let Java C know that we're compiling the source code intonation mods org-astro. The source file is the one world source file and the module info file as well. So the module info file is just a regular Java file from the point of view of the compiler, and it creates, as it usually does, just a regular class file out of it. So the result of this is a module info.class file. And if we run this to the Java PD assembler, we see that it outputs the corresponding module info declaration that's stored in the bytecode. Then we'll build the application. And this time, we'll pass the option -p to Java C. -p tells the compiler and the VM what the module path is. So the path where modules are stored. We just built one. So during the compilation, the compiler will fetch the compiled module and resolve and build our application module against it. And so a big benefit here is, of course, module path, just one letter, P, versus 2 for class path, CP. So that saves you typing. Okay, so we build this thing. Let's run it. And again, you'll see -p for module path. And it outputs greetings world as expected. So we've compiled 2 modules, application, they resolved against each other. At compile time, at build time, they run. Great. Now that it builds, well, let's just ship it. And the way you do this in the JDK-9 modular world is using good old jar files. In particular, they're now called modular jar files because they contain, in addition to the bytecode itself, also a module info class file in the root level directory. And one of the nice things in 9 is that the tools can take GNU-style options. So, yay, GNU, right? You can say jar -- create instead of -c, file and so forth. You can also, if you want to pass module versions to the modular jar files you create, but those are not used by the system to resolve modules actually, but they can be stored there in their names and as metadata. Jar tool also has an option to describe modular jar files it finds, again by reading the module info class file in a modular jar file and letting us know that, for example, in this case, the module org-astro at 1.0 exports the org-astro package for use by its users and requires, as any module would do, the base module, which contains things like Java-Lang object. So we've created a modular jar file out of our library. Let's make one out of our application as well. Again, jar create. We also can pass in a main class attribute here. And then we get a modular jar file that looks like this. So we have a module called greetings in this jar file. It requires Java base, it requires the org-astro module, it contains the com-greetings package, and it has a main class called com-greetings main. Now we can link the application with the library with the parts of the runtime it requires, and in this case it's only going to be Java base because both modules require Java base and nothing else, no swing, no Corba. So we use the JLink tool, pass it the archive of modules we built in mlib, the archive of modules in JDK, that's the JMods one, and tell it to add the module's com-greetings application. We don't have to specify the dependencies here because they'll be automatically resolved. And to output the result into the greetings app directory. And what we get in the greetings app directory is a lot of files that are basically what you would see in a runtime. A Java exe, a bunch of DLL files, a bunch of policy files, all that good stuff. Where did our application and our module go? Well, JLink has linked them all together into a single file called modules. They've been all meshed together, along with corresponding bits and pieces that are required from the JRE itself. And so there is no RT-jar in here, there is no tools.jar, none of that stuff, just the bits we need. And we can run the application, running the Java launcher from the customized runtime we just built with JLink, using -m to let the runtime know which module we want to run, in this case com-greetings, and it'll say greetings world. So we just built a custom runtime that does one thing and does it well, and hopefully we've saved a bit of space, right? Let's see if we did. So, well, you know, it's 30-something megabytes. Can we do better? Yes, we can. We can use JLink to, for example, compress the resulting output a bit further. We can tell it to strip debugging information, for example. And in this case, we'll end up with something that's quite a bit smaller. So the stripped runtime and compressed runtime for this code ends up being only 20-something megabytes. That's quite a bit of saving. And if you really want to, you can go even smaller. So if you look at the JLink tool and its helpful help page, you'll see it has a number of options. In particular, it has a list plugins option. And looking at that, you'll see there's a number of things you could do in addition. For example, you could strip out the native commands. You could pick out a different, for example, a minimal virtual machine, so you don't have to have the different compilers in there. You could exclude particular locales. You could, do a whole bunch of other things to try to bring the size further down if that's of importance to you. But having a 20 to 30 megabyte base to start with, I think is quite a big win using modules in 9. And if you want to play more with modules, there is a quick start guide on the Jigsaw webpage that goes through examples like these in a lot more detail. Okay. And now to something completely different, right? Docker. You may have heard about Docker, and so have people at Oracle, surprisingly. And a number of people have asked for the Oracle JRE to be made available in some form on Docker. And Oracle has heard those people as well. And so a couple of weeks ago, we've announced an official Docker image for Oracle Server JRE on the Docker store. That means if you sign up to Docker store, you can Docker pull store /Oracle/server JRE and get the latest server JRE from Oracle from Docker directly. This is, I think, ATU131 based on the Oracle Linux 7 small image or slim image. So it's about, I think, 380 megabytes of goodness. And it's not the only thing we've done here. So in 9 in particular, we've done a number of things to make the JDK a bit more aware of environments such as Docker by making it more aware of the limits in particular that Docker can set for CPU and resource utilization, which tend to be slightly different from the ways the kernel does it. So there's been a bit of work on a number of changes to make the JVM support, execution, automatic configuration in those environments better. This was done for 9, and it was backported for 8 as well. So if you're using ATU131, you'll be able to benefit from the same improvements. And if you want to know the details about to utilize them, you can find all these in the corresponding issues in our OpenJDK bug tracker, or of course in the release notes. So that's good, right? But there is more we're doing around making you more productive around containers and cloud and these things. In particular in OpenJDK, we have a new project since a couple of months called Portola. As the name implies, it's a port. It's a port of the JDK and the OpenJDK to the Alpine Linux distribution, which, as the name implies, is a Linux distribution. So it has the Linux kernel, on top of which sits a tiny custom libc, system C library, called Musel, surrounded by the customary embedded systems BusyBox userland, and that's the nucleus of distribution, right? And that makes Alpine really tiny. So its minimum configuration is about, I think, 5 megabytes. And it makes it very attractive for people building, for example, containers as a baseline. And work on this port has been ongoing for a couple of months in the OpenJDK Portola project. It was initially going with a target of JDK-10, but in the recent weeks, it's been backported to 9. And so if you're adventurous enough to check out the JDK-9 repository of Portola, you can basically build something that lets you link small runtimes of, let's say, 20 to 30 megabyte size for a Linux distribution that's about 5 megabytes size minimal. You end up with something that's about 30 megabytes to begin with. And if you compare that with what's available today, say JDK 8 image of server JRE on Docker that's 300 something megabytes, that's about 10 times less space. And every time we do something 10 times better, chances are you open up interesting opportunities for innovation to happen to save space and save money and so forth, and make developers more productive along the way. So I think that's fairly exciting. And I think that's what makes J-Link and Portola and these things something to very much look forward to as developers. But there is more in Jigsaw. The other aspect that I think is very important is the whole safety aspect and security. And so if you've been developing JDK for a while, you're familiar there is a lot of APIs in JDK, some of which are supported, such as Java something or other, some of which are not supported, such as Sun, MISC, internal, don't touch this. as the name implies. Those are JDK-internal. Nevertheless, even if you put up a warning sign that says, do not do this, some people will do it anyway. And sometimes they'll end up using APIs that over time get replaced and have safe replacements, such as SunMISC base64 encoder-decoder. Sometimes they'll end up using functionality that has no replacement yet in the JDK, such as SunMISC unsafe. And that, of course, creates a bit of a problem, because a long, long time ago, when Java was published, Sun published documentation along with it. So, as you can see, 90s documentation, much longer than Twitter rants, a lot of text. One important line that says, the Sun packages are not part of the public supported Java interface. A Java program that directly calls it is not guaranteed to work on all platforms. In fact, it may even break on future releases. That sounds ominous, right? And so some people read documentation and said, well, maybe we shouldn't do this, and didn't do it. Good. Some people read that and thought, that's a challenge. Let's see what I can do. And I guess most people just ignored it, as we usually do, right? So fast forward 10 years later, 2006, the problem kind of grew over time. And so the next attempt to address it was to have the compiler in Java 6 warn you if you were using such APIs directly. So the compiler would output a message saying, hey, you're using a some proprietary API here. Danger, Will Robinson, your code may break in the future. And guess what happened? Like pretty much the day after an early access build was published with the compiler having such a warning, there was, I think, 1 or even 3 bug reports saying, hey, the compiler here has a bug. It has a warning about me using APIs I shouldn't be using, and I can't turn this warning off. The compiler is wrong. I want to suppress this warning. I don't care about it. Well, those bug reports, of course, all got closed pretty much the same day, because that was the whole point. The compiler was supposed to warn you. You weren't supposed to turn it off, that you were doing something that may lead to problems down the road. In particular, if, as this comment from an evaluation from 2006 says, if the proprietary APIs all get shoved into a separate module and made inaccessible, such code will break. And so warning developers about it was a good idea. Little did it do, of course, to prevent people from using those APIs, because they could still just use reflection and all kinds of other hacks to access them. And that changes with 9, because with 9, most of the internal APIs are actually encapsulated, so they're not made accessible by default to such code. And encapsulating means that both the compiler, in this case through the module declarations, know what APIs you're supposed to use and which are not exported for users of libraries, so you're not supposed to be able to access those. And also the JVM knows the same thing based on the same information. And so it prevents such accesses at runtime, regardless whether you have code you've built with, say, Java 5 that tries to mess with Sun don't touch this APIs, or if you're clever and use reflection or set accessible to try to get around it. The JVM still whacks you on your hands and says, no, this is supposed to be JDK-internal. Please don't do this. That being said, there is still a handful of critical APIs that are widely used, such as SunMISC unsafe, which don't have an adequate replacement in JDK-8, and those remain accessible by default in 9. And so your code that relies on some random unsafe hack will probably continue to work as it is in 9. And it'll be supported until replacements exist in a future JDK release. Now, you may have your own code you wrote with such hacks. In that case, congratulations. Now is a good time to look into fixing it. But more often than not, you may have had somebody else write a code that you end up maintaining, and you don't quite know if they had such, Stack Overflow-induced traumas in your code base, where somebody looked something up and thought it's a modifying an unmodifiable collection using set accessible was a good idea, after all. Why wouldn't you? It worked on Stack Overflow. And so what do you do, right? In particular, what do you do with third-party libraries? And for that, there is a tool in JDK-8 and JDK-9 called JDEPs that you can use to statically analyze your own code and your libraries and see if they have any dependency on JDK internal APIs that are not accessible in JDK-9. And so this tool is called, let's see, JDEPs. Let's clear this. So, for example, you can just pass it a jar file, and it will tell you that, for example, in this case, the and JavaFX jar file depends on the Java base module, the JDK packager module, and on the not found module. The not found part, what's that, right? I never heard of that one. So let's try to make it verbose. -v. And then we'll get flooded by output, some of which says something about org Apache, not, so that's probably that, right? I don't have and to my class path, but I now know that this jar file depends on basically two things from the JDK, the base module, obviously, a packager module, and a bunch of third-party stuff. Okay, but this is very noisy, so I want to constrain the verbosity to just a package level output, because I'm still trying to analyze if I have a problem and what the scope of the problem is. And in this case, I can see that my packages I have here do not actually seem to depend on any internals. So let's see if that's true by passing in the JDK-internals flag to JDEPs. And it says, yep, no output. So that's fine. This jar file doesn't have any internal dependencies. But it would be too easy if I show you something that just works. So in particular, because my colleagues have cleaned this file up, I have prepared a version of the file from a couple of builds ago that had a few problems. So let's try that instead. And as you can see here, there is actually an internal API output over there where it says the tools and package has a dependency on JDK packager internal package, and the name internal kind of implies shouldn't be using this, and that's actually a JDK internal API. And so JDEPs lets us explore the code and find out, for example, if the JDK internals usage is part of the API through the API only option. That means if the types being used here are actually exported, are part of an interface or part of a class, part of a public method, or not. So that we can get a sense of how deep the rabbit hole we need to go, how much of a problem we have. And if, in this case, something is actually an internal class, part of the internal implementation of a class, it's much easier to fix without affecting consumers of this library. And for more on JDEPs, I suggest checking out the main page and the JDEPs tool itself. It's quite a neat, powerful tool that gives you a sense of, problems you might encounter in dependencies. Okay, what else have the modules done for us, or could modules do for us? The third goal here is to enable improved performance. And if we know a lot of an application, if we know its architecture, if we know what it's built from, so to say, we can build it, right? So we can compile it to bytecode, but we can do a bit more. We can pre-compile it ahead of time to native code before we launch the VM at installation time. So there's a new tool in JDK-9 called JAOTC, ahead of time compiler. It uses the Oracle Labs provided Graal project as the compiler backend, and it stores the result of the compilation, both the compiled code and the metadata, in a shared object file, your just regular Linux, SO file, which then can get loaded during startup to improve the startup time, while having a limited impact on performance. And it can also be, because it's just a native library, shared across a number of different processes running on the same system. And that becomes interesting, say, in build servers and so forth. And so ahead of time compilation is not a panacea. It won't make your code go 10 times faster, probably, because it addresses the factor down here, the method warm-up time, where the method is still running an interpreter. And by using ahead of time compiled code, we can replace this and move on to basically have precompiled code run instead. But I think it's a fairly interesting feature to improve startup time of application, which is something that, in particular for short-running code, has been a feature a lot of people have asked for a long time. It's experimental in 9. It's currently supported on 64-bit Linux. It's currently limited to Java base module. And as with other features, we would really like to get your feedback on your experiences. We can try it on your own code. But I think it's one of the very fun features of 9 for developers. If you want to know more about this feature, today, in the room next to this one, 11, my colleague Dmitry is going to be going into a lot of detail about ahead-of-time compilation at 16:20. And last but not least, another goal of Jigsaw is to make it easier for you to construct large applications and maintain your libraries using a module system. That's ultimately a goal where the proof is in the pudding, where it's up to you to, as your homework, grab a JDK-9 LXS build from jdk.java.net, try it out yourself, and see what kind of benefits you get from using the module system and how hard it is to adjust your own libraries to it, and get your own experience with it. If you do so, hop on Jigsaw.dev, let us know how you get along with it and what problems you face. There is a number of developers who are happy to kind of help you out and provide advice on dealing with all kinds of things you might encounter. But in any case, do try to play with this and try to see what kind of benefits you can get from using the ahead-of-time compiler, from trying to shrink the runtime to just dependencies your code needs and so forth, and see if this is something you find useful in your work, makes you more productive. In 9, there is a whole slew of other features. So there is features across the board that go from tooling. There is a new shell, a REPL, over to the VM. There's a whole bunch of features on the VM side, to the class libraries. And I think Simon is going to talk about this in more detail right after this talk. So I won't cover the features in any other detail here. I'll just mention one thing. We had, with Jigsaw, smaller, we had safer, we had slightly faster at startup. There is one more thing that people tend to complain with Java is it's not really known for being resource, not being resource hungry, let's put it this way. And there's a change in 9 that I think can be quite helpful here. If you look at Java strings in 8 and before, strings are internally stored as an array of characters. And each character is actually a UTF-16 encoded 2-byte value. UTF-16, that was what it was a long, long time ago. I'm sure it made sense back then in the 90s. But meanwhile, the world has changed. There's a lot more UTF-8, for example. And if you look at commonly used strings, for example, those in, say, UTF-8 in many cases, or in Latin 1 encoding and so forth, you'll notice that their in-memory representation ends up, having a lot of very similar characters, a lot of zeros in the hello string here, for example, because we don't need this second byte. If we only use, Latin 1, or in many cases UTF-8. That's a problem in theory on a slide. Is this a problem in real life? So in the course of development of 9, we've done a number of tests with a number of heap dumps from a variety of applications. And it turns out that the footprint of those character arrays used to store strings makes up a significant amount of memory being used by real applications, as well as benchmarks and so forth. So it makes up to between 10 and 45% of live data. And what turns out to be fascinating is that the majority of these characters are actually single byte. So there could be significant savings here. And as the work went on, it was predicted it will lead to saving of around 5 to 10% of footprint. So that in 9, this was done successfully, and now in 9, the string implementation has slightly changed. in a way that's transparent to users, unless you find yourself messing around with string internals for whatever reason. You shouldn't be doing it as a private field, after all. But there is now a private byte field that stores the value of the string. And there is a corresponding byte that stores the value for the encoding which is being used, so that the strings that used to be, double the size can now be just half the size, plus one more byte, right? And this ends up being, I think, quite interesting in practice, because what we found out on applications such as benchmarks and micro benchmarks and industry benchmark is that this improvement leads to basically less memory being used by the VM in many cases, which means there is fewer need for GC cycles, which can improve throughput, which can even improve startup time, because less stuff needs to be shuffled from jar files into memory space and back and forth. So I think even if you say memory, or if you say module systems, fine, but I have no use for this just now. Even if you say a lot of other features in 9 are fine, but I don't have any use for them, moving on to 9 to be able to profit from the VM-specific changes such as these can be quite a benefit of its own. So that too should be a good reason for you to evaluate 9 for your own needs. In particular, at this point in time, where we are just a couple of weeks from a release, where your feedback is crucial in helping us detect any significant regressions and helping us fix those in time. If you are participating in an open source project, I'd like to invite you to join us in the quality outreach, where we regularly reach out to lead developers on major open source projects when there are new builds, so they can let us know if a JDK9 build, for example, fails in some exciting way or the other, so we can try and find regressions before we get to a GA point. So if you're interested in that, please approach me after the session, and I'll be happy to give you a pointer. Otherwise, just hop on the quality-discuss mailing list in OpenJDK, and we'll be happy to help you, get set up there as well. So what can you do to prepare for this? Like I said, hope you can get them built from JDK.java.net side. Try it out yourself. If you're, for some reason, are running on a platform that doesn't have a build up there yet, no worries, the code is there. You can just build it yourself. If you're running, say, Debian on an Amiga, AG clone the code, run, make, configure. It may take a while on an Amiga, so be prepared to bring like a week of time to build it, but hopefully it'll build. You can read documentation, so there is JDK9 migration docs on the Docs Oracle.com website that go into a lot of detail of what you can do to update your libraries, update your code, exploring some of the things I said here in more depth. You can check your own code and your dependencies using JDEPs, fix the issues you find in your own code, maybe file bugs on third-party libraries you have that may still have issues left over, so those get fixed in time as well. Check your code's dependencies on the JDK internal layout, because this has changed as well slightly. So RT-jar is gone in the modular world, for example. Tools.jar is gone in the modular world. Check if your code is sensitive to some other changes, such as the versioning change in 9, where the JDK version itself now uses a more custom 9.0.1 format, except rather than the 8U prime number or whatever it was before. And most importantly, test your code and let us know if something fails. And with that, I'll leave you to the safe harbor statement. No, I'll leave you to some last questions and hopefully answers, if there are any.
Anyone? Okay.
Finally, Jigsaw will be included in JDK-9. I'm sorry, and finally, will Jigsaw be included in JDK-9?
So the JDK9, so the Java 9 JSR has passed the public draft review last week by the EC, and it includes an explicit reference to Jigsaw. And I think that should be a sufficient hint in that regard. One more minute. If there are no questions, then, oh, there's one.
Yeah, how does this compare to the OSGI manifest declaration of requirements and exports of modules and bundles?
And we're out of time. But yes, that's a question I think that needs a slightly longer answer. Ultimately, Jigsaw and OSGI address very different layers of functionality, where Jigsaw is more about static configuration in a sense. OSGI is more about dynamic configuration and services. They have, in some ways, certain things they do in similar ways, but they also have many things in different ways. And if OSGI works for you the way it does today very well, just keep using it. If you want the benefits of Jigsaw, explore it and see what it can do for you, for yourself. Okay. And with that, I think we're officially out of time. Thank you so much, and see you at JDK 10 time.